Right, so today I will show you how to draw a image using the Fanuc, a robot arm. So basically the first thing you're going to do is to download the materials here. So what you can do is you create a new folder on your desktop. And then you save the files I have uploaded. So now you open the folder, you can see all the files are here. And then now you open up the MATLAB program. Right now, so we have opened the MATLAB, and then what we are going to do is, you can see right here, it asks us to create a test.csv. So what we are going to do is to new and then create a text file, and then we rename it as test. And then for the txt, rename as CSV. Now we're good. And then we go over here and run the program. Then we ask you to select an image. And then here you change all files into all files. And then you select the image right here, click open. Then we will start processing. So as you can see right here, we have one of the results which we will get. And for the code, I can explain to you. So basically, after you opened, you can change the scale value. For example, you can change it to 100 or 10, which will be smaller than the current one. And then the lift pen height is for the Z value, which you can change it to 20, and it will lift up for 20 millimeter, which is 2 centimeter. And then for the origin, you have to test it using your robot arm. So you put your robot arm in the center of your paper and you see the origin, and then put the origin right here. And here for data, the distance apart we want to record. For example, right now we want to record 2 points which are 0.001 apart. And then for the offset is for the Z values, which we can add it here, or we can do it in the program, but here is much easier. And here yaw, roll, and pitch is for the robot arm to hold the pen. So for example, you put the pen in the middle, and then you record the position, and then you record the yaw, roll, and pitch. Then you put them here. And as you can see, the first step is initialization. And after the initialization, we will acquire an image from user selection, which you choose an image, and then we will read the image and detect the edge. After detect the edge, it will do skeletonization of the image, which extracts only the useful lines which we will draw. And then we detect the start and end points to see where it will go. Like, for example, one line. If it's one single line, we want the robot arm to draw it from beginning to end. And then the other line, it will lift the robot arm and then go to another line and then start drawing. After that, we find sort the points and create the path for them. Finally, we create 3D coordinates, which we store them into a matrix, and then right now we have 3 coordinates, x, y, z, and then we find the center point of the graph, which we have to shift them to 0.0 and to our new center point. And then for this step, we can find out that the new graph is located in our new center point. And then for the z-axis, we have to increase it because after you draw one line, you have to lift up your pen, and then to a new place, then you put down your pen. That is why we have z-axis. This one is the same for the z-axis, except for this one is for starting of the new line, this one is for end of the previous line. And finally, because the Fanuc software requires yaw row pitch as well, so we have to include them, and you can set it in the top. Finally, it will write the whole matrix into a CSV file. Right, so we can see our output right here, which is test CSV. And by the way, for the code of the MATLAB, you can click on the link which I put in the video description, and you can follow the link to get it. Alright, so now we have successfully export the points to the CSV file. So we are going to open up the Roboguide. Alright, so as you can see right now, we have finally opened, and then we can go ahead and go to the targets, and you click on import point data, and then you select the file, which is the same folder we have used recently, and desktop, new folder, then test CSV, then you click on OK. So basically it has around 3,000 points, so it will take some time to import. And then the next thing we're going to do is create target groups. So click on add target group, and then set your tool frame and user frame. And in my case, the user frame I had is number 8, and tool frame is number 9. So user frame number 8, tool frame number 9, and I click on OK, and then I click on the target group, right click, edit target group, and then here we click on members. Then we select the targets from number 1, shift select to the end, and then click on or add all process to job. Then click on OK. And you can see the points right here. And another very important stuff we have to do is we have to deselect the approach and retreat. So we select the first one and then go to the end, shift select. And then we go to motion line data, deselect both approach and retreat. Because for this one, if you leave them on, it will be like 1 point up, 1 point down. We do not want that. We have to have one continuous line, which is no approach and no retreat. Right, so now it's finally done, and then we can rename the program as TG5. And then click on Generate Feature TP Program. Alright, so now I have finally exported the stuff, so I close it. And then you can see right here we have a lot of points. And right now I can just make the target groups invisible. And then what we have left will be only for the program, which is TG5. And then now we can click open TG5. We can see it has all the points stored, and they will go follow the points until the end. So what we can do right now is we can export it and to the robot arm. So we click on save and save as binary. And for the remote disk, you go to the Android data and then JP files, and then you can save right here. Okay, now we have the file, and here I can show you another thing we can do to offset. So basically you can click on here, here the programs, you click on load program. Oh no, so basically for here you can save as text file, and I save at the same place but give it a different name. It's called offset. So after you've done that, you can go ahead and open the file we just saved. And for the LS, we can open with the notepad. And as for here, we can add an offset, and which we can easily change later. So basically, we can go to File, Edit, Replace. So we are going to replace the CNT 100 with offset with point register 40, and so basically this is the thing. So we click on replace all, and you can see now it becomes CNT 100 offset PR, and this is quite useful. We click on save, close it, and then we click on load program, and then load the LS file we just had. Click on open, and then click on over the existing. So this one now is with all the offsets, and that's a quite convenient feature. So we have to, next step is to save it. So now I have come to the robot arm, and here is the pendant, here is the USB. So the first thing is to insert the USB into the pendant, which is right here. And then we go to File, Menu, and then we go to File, and then we go to Until, then we go to Set Device, on Pendant, and then we click on all the file, enter, and then we can see the TGF file is right here, and then we can load it. Click on load. You want load? Yes. Now it's loading. It says it's loaded, right? So we go to select number 5, and then here we can do the manual stuff right here. Then we can click on and right now we can click on play. Yes. Then we change the override to Right, so now you can see the robot has finished it, and the image is decent, I can see. And for some final thoughts about the position, you have to go to the center and record the position, go to the both sides, record the position, and then you can set the scale value.